What is the farthest place humans could ever reach? The question sounds simple enough to fit inside one breath. What is the farthest place humans could ever reach? It sounds like the kind of sentence a child might ask while looking up at a clear winter sky, or the kind of sentence an old civilization asks when it has finally grown tired of pretending that nearby victories are enough. Yet inside that sentence lies almost the whole architecture of the universe. Distance, time, biology, engineering, memory, light, gravity, expansion, mortality, and the strange stubbornness by which intelligent life keeps trying to turn the unknown into a future. At first, the mind imagines the answer as a location, a star, a galaxy, perhaps the edge of the visible heavens themselves. We are trained by maps to think in this way. A farthest place ought to be somewhere. A point, a last province, a final coast where the road ends and everything beyond becomes too distant, too hostile, or too impossible to cross. But the universe resists that grammar almost immediately. The farther one thinks, the less the ultimate frontier resembles a cliff or border, and the more it begins to resemble something stranger, a moving limit written into the relationship between matter, light, time, and the expansion of space itself. That is why this question becomes so powerful. It does not merely ask how ambitious humanity may become. It asks whether the future itself has a wall. It asks whether there is a final horizon beyond which no ship, no habitat, no relay chain, no generation, no machine, and no transformation of the species can ever go. In a deeper sense, it asks whether the universe allows a civilization to keep converting patience into distance forever, or whether even patience must finally meet a law more ancient than desire. The first humiliation is the nearest star. Human beings often speak of nearby stars with a kind of accidental dishonesty, not because they intend to lie, but because language was built at scales too small to carry the truth cleanly. Proxima Centauri is called our nearest stellar neighbor, and the word neighbor makes the mind careless. A neighbor is someone across the hall, across the field, at worst across a short road. Proxima is not that. Light itself, the fastest thing we know, requires more than 4 years to cross the distance. A human spacecraft, carrying mass, shielding, life support, and error, would need far longer unless physics is bent by technologies that remain speculative even in their most generous mathematical forms. This matters because the nearest star is not the farthest place humans could ever reach. It is the first place that teaches the emotional scale of the whole problem. If even the closest sun requires years for light and perhaps decades, centuries, or more for practical human travel depending on the method, then the future cannot be judged by adventure alone. It must be judged by whether a civilization can survive the kinds of time such travel demands. Another star does not first test engines. It tests patience, continuity, and the willingness of one generation to act for another. That is why the path outward would likely begin not with triumphant leaps, but with the invention of long discipline. Ships that do not require one lifetime to complete the story. Habitats that can remain coherent while moving. Archives that do not die when founders die. A culture able to call a 50-year crossing early rather than late. Before humanity asks what the farthest reachable place is, it must first decide whether it can become the kind of species for whom distance measured in generations is still morally legible. Once that first lesson is absorbed, a second follows. The future may not belong to one magnificent voyage aimed heroically toward one remote prize. It may belong to branching. That difference changes everything. A civilization that tries to reach a single far destination in one continuous act faces the full cruelty of scale alone. A civilization that spreads by relays, settlements, reproducing habitats, autonomous construction, and slow multiplication can make modest velocity more powerful than spectacular speed. The frontier then does not move because one ship becomes miraculous. It moves because many worlds, once established, launch again. This means the nearest stars matter less as individual trophies than as the beginning of an archipelago. Reach one, and it becomes a base for reaching others. Build a habitat there, and distance starts to change moral character. What was once an unreachable gap becomes one more link in a chain. Over thousands, tens of thousands, or hundreds of thousands of years, such chains can turn local stellar neighborhoods into civilizational geography. The universe is still immense, but the way one measures immensity has already begun to shift. There is something profound in that. Humanity may not conquer distance by one final act of speed. It may domesticate small parts of it through persistence. This is humbler than science fiction often likes, and far more interesting. It means the future belongs less to the fantasy of effortless travel and more to the art of creating durable stepping stones under alien suns. Before humanity spreads among the stars, it would almost certainly spend vast ages learning how to become distributed under one star. The solar system is often drawn as a tidy diagram and therefore emotionally minimized. In reality, it is already a continent of civilizational possibility. Earth, the Moon, Mars, the asteroids, the Jovian system, the Saturnian moons, orbital habitats around the Sun, industrial stations near Mercury, buried cities in the outer dark, all of this could occupy thousands and perhaps tens of thousands of years of human ingenuity without making the system feel small. This matters because the solar system is where the species would first learn the habits required for its farthest reach. Closed ecological cycles, radiation management, long-duration habitation, distributed governance under communication delay, economies built from asteroid material rather than planetary abundance, rotating worlds made by engineering rather than geology. The culture that someday asks seriously whether another galaxy is reachable will likely be the descendant of societies that first learned how to live in cylinders, under domes, inside rock, and within the precise arithmetic of finite air and water. One may even suspect that the true beginning of humanity's ultimate reach lies here, rather than at the first interstellar launch. The species does not become galactic by suddenly becoming bold enough. It becomes galactic by first learning how to survive in places where survival is no longer an accidental gift of planetary history. The solar system would be the training ground, not because it is easy, but because it is the last place where help can still move within something like ordinary time. In that long early age, habitats may become more important than planets. This idea still feels emotionally strange because human beings inherit the planet as their primary image of worldhood. A world ought to have a horizon, weather, oceans, gravity, and a sky that belongs to deep geology rather than design. Yet the logic of expansion may eventually make artificial worlds the true workhorses of civilization. A rotating cylinder can provide chosen gravity, its climate can be regulated. Its position can be optimized near resources. Its size can grow by engineering rather than waiting for nature to offer another convenient planet in the right place. This shift is important because it changes what reaching means. If humanity can build worlds, then the farthest reachable place may not always be a natural destination waiting to be occupied. It may be a region of space where life-supporting structure can be created. In that future, the species does not merely travel to worlds, it carries the capacity for world-making with it. A barren system becomes less an obstacle and more a materials field for deliberate habitability. This does not make distance trivial. It makes the traveler more self-sufficient. The farthest reachable place would then be determined not only by how far ships can go, but by how much civilization they can carry in compressed form. Ecological knowledge, machine systems, stored genomes, fabrication capacity, energy discipline, and the cultural will to turn raw matter into home. The frontier moves outward when humanity learns that home can be made as well as found. Suppose, then, that interstellar expansion begins in earnest, not through one grand empire, but through a spreading family of settlements. Some stars are reached by generation ships, others by embryo missions, machine swarms, suspended populations, or self-building infrastructures sent long in advance. Some destinations are chosen for planets, others for asteroids, stable energy conditions, or mere strategic positioning as future relays. Over enough time, the local stellar neighborhood thickens with human or post-human presence. What would this mean for the question of the farthest reachable place? It means that in the short cosmic term, the frontier would not be the nearest star, nor the next few, nor perhaps even the local spiral arm. The frontier would keep moving as long as each reached system retained the capacity to launch again. Distance becomes less a single great wall and more a repeating test. If continuity survives, the test can be taken many times. This is why 1 million years, 10 million years, or 100 million years matter so much more than one triumphant century. The universe punishes impatience, but it does not necessarily defeat persistence. A civilization that can remain alive, distributed, and technically literate long enough may push itself outward through local space not because any single journey is easy, but because many hard journeys can still accumulate. The stars nearby become a region, the region becomes a network, the network becomes history. The Milky Way, however, is where the scale becomes morally different again. It is one thing to imagine a few dozen or even a few hundred light years of spread. It is another to contemplate a galaxy roughly 100,000 light years across. Even with steady branching, the full galactic disk remains an arena so vast that any single human-style civilization would dissolve into plurality long before it could meaningfully experience the whole. There might be human descendants on opposite sides of the galaxy who share origin, biology, or machine ancestry, and still know one another only through delayed archives, deep surveys, and reconstructed kinship. Yet the Milky Way is not beyond thought. This is what makes it such an important threshold. A species does not need impossible engines to become widely galactic across deep time. It needs survival, replication, and patience. Given enough millions of years, even modest but repeating interstellar settlement could seed large portions of the galaxy, especially if some branches become very efficient at self-building habitats and sending out new missions. The farthest place humans could ever reach may therefore include enormous stretches of the Milky Way, not because the galaxy becomes small, but because time becomes cumulative. Still, this does not mean every part of the galaxy is equally inviting. The galactic center is harsh with radiation, dense stellar neighborhoods, and dynamic gravitational environments. Some regions may remain culturally marginal or scientifically prized rather than heavily settled. The halo and its dwarf satellite galaxies may become places of strange, sparse outposts rather than dense human worlds. Reachability does not imply uniform colonization. It only means that in principle, over enough time, human or descendant life could touch far more of the galaxy than present intuition comfortably imagines. The local group then enters the story, and with it the first truly unsettling answer. Our galaxy is not alone. It belongs to a gravitational family that includes the Andromeda Galaxy, the Triangulum Galaxy, and many dwarf galaxies. Unlike the broader universe, the local group is bound together strongly enough that cosmic expansion does not simply tear it apart in the way it separates more distant realms. The Milky Way and Andromeda are themselves on course for a future merger over billions of years, part of a long gravitational dance rather than an irreversible cosmic flight. This matters enormously for the ultimate frontier, because if one asks not what humans could reach soon, but what they could ever reach under the most generous span of survival, then gravitational binding becomes morally and physically decisive. Regions that remain bound to us are not merely visible relics. They remain, in principle, members of a connected future. The local group may therefore represent something like the outer durable realm of practical belonging, the largest structure within which an arbitrarily patient civilization might still hope to move without fighting the full long-term exile imposed by cosmic acceleration. This does not mean the whole local group becomes easy. Crossing between galaxies would still demand extraordinary durations or extraordinary propulsion. But it does mean that if humanity endures for sufficiently long spans, the farthest truly stable region it could hope to inhabit may not be the visible universe at all. It may be this bound family of galaxies, gradually becoming more internally significant as the rest of the cosmos retreats beyond meaningful reach. Andromeda, in that sense, occupies a special place in the imagination. It is close enough to matter, far enough to remain terrifying, and gravitationally tied to our own future in a way that many more distant galaxies are not. A civilization that had already spread widely through the Milky Way might one day attempt the long bridge to Andromeda through extremely patient missions, relay chains, or descendants that have ceased to require fast results. That bridge would not resemble exploration in the old heroic sense. It would resemble the expansion of a second continent across an ocean so wide that entire civilizations could rise and fall while one side was still crossing toward the other. There is something almost epic in the thought that the farthest place humans could ever truly call part of their long future might not be a remote, lonely galaxy glimpsed in isolation, but another member of our own bound galactic family. Over immense time, the Milky Way and Andromeda would merge into a larger remnant anyway. The distinction between reaching Andromeda and remaining within the history of our own gravitationally bound realm may therefore soften across cosmic ages. The far frontier begins to look less like flight from home and more like patient maturation inside a family of galaxies that will one day become one deeper house. This is one of the first hints that the final frontier may be defined not by the most spectacular thing visible in the sky, but by what remains causally and gravitationally available to a civilization even after the universe grows older and lonelier. Beyond the local group, the mood darkens. Intergalactic space between larger groups and clusters is not only vast, it is subject to the deeper consequences of cosmic expansion. Distant galaxies are not merely sitting very far away like islands on still water. Their separation from us grows because space itself expands. The farther away a galaxy is, the stronger this recession appears, expressed through cosmological redshift and the overall expansion history of the universe. NASA's Hubble science materials and broader cosmology resources emphasize that this is not simple, ordinary motion through static space. It is the large-scale behavior of space-time itself. That changes everything about reach. A distant galaxy can be visible and still not be meaningfully available. We can receive ancient light from structures whose later states are receding ever farther as the cosmic fabric stretches. The dream of visiting whatever one can see begins to fail here. The sky shows much more than the future can claim. Observation and access separate. The universe becomes legible in regions that civilization may never touch. This is emotionally devastating because it violates a deep terrestrial assumption. We are used to believing that enough effort turns the visible into the reachable. Mountains seen can be climbed. Coastlines seen can be approached. Even the moon, once a symbol of untouchable distance, yielded to engineering. The cosmological scale destroys that habit. There are things in the sky whose light enters us and whose future will never belong to us. The farthest place humans could ever reach must therefore be sought not in the full visible universe, but in the smaller and harsher realm the universe keeps causally open. This is where dark energy and accelerating expansion become central rather than decorative. Cosmology now describes a universe whose expansion began accelerating several billion years after the Big Bang, driven by what we call dark energy, even if its deeper nature remains unsettled. NASA's dark energy materials and WMAP results both emphasize that this acceleration changes the future structure of cosmic access. Galaxies outside local bound systems do not merely drift away slowly forever. In many cases, they recede into practical irrelevance, crossing from difficulty into permanent inaccessibility. What this means for the script is profound. The ultimate boundary to humanity's future may not be a line on a map. It may be the event horizon of an accelerating universe, a limit beyond which influence can never again be exchanged. Such a horizon is not a wall in space, it is a structure of causality. It tells us that some regions, however visible their ancient light may remain for a time, are no longer participants in any shared future with us. The farther they are, the more that shared future evaporates. This gives the question its strongest and saddest answer. There may indeed be a definitive frontier to what human beings could ever reach. But it is not the edge of the observable universe in the cinematic sense. It is the boundary between what remains causally available and what cosmic acceleration slowly removes from relationship altogether. The distinction between the observable universe and the reachable universe is therefore one of the most important ideas in the whole subject. The observable universe is the region from which light has had time to arrive since the early universe became transparent. It is a horizon of observation. It is not a guarantee of access. NASA's overview of the universe, its redshift materials, and related cosmology explanations all support this broad picture. What we can observe is defined by time, light, and expansion, not by a neatly navigable outer shell waiting for explorers. This means much of what we see is already, in the deepest practical sense, not for us. A civilization may study it, model it, admire it, even derive identity from the knowledge that it exists. But study is not settlement. Vision is not approach. The farther the universe extends, the more one realizes that the sky is not a menu. It is partly an archive of things whose light still reaches us after their futures have already fallen away from our own. That is why the title question becomes more interesting the better one understands it. It no longer asks how brave humanity might be. It asks what the universe itself allows relationship to remain. The final frontier is not the farthest thing seen. It is the farthest thing that can still join our future before space-time closes the route. Suppose, however, that technology becomes almost absurdly advanced. Suppose ships reach substantial fractions of the speed of light. Suppose habitats survive for ages. Suppose minds can sleep, migrate into other substrates, or distribute themselves through machine ecologies. Suppose artificial worlds can be built with astonishing efficiency. Does any of this erase the cosmic limit? It changes the scale of local possibility immensely. Near light travel would compress subjective experience. It would widen the region a civilization could practically seed before biological timescales feel prohibitive. It might make the galaxy, or at least large fractions of it, more emotionally and logistically accessible than they would otherwise be. It might even make crossings between bound galactic systems conceivable over heroic spans. But it would still not automatically dissolve the causal structure set by expansion. There are regions so far and receding in such a way that faster ships do not simply restore them to availability. Some separations belong to geometry, not to insufficient engineering. This is a sobering result. Even the most ambitious future does not necessarily transform the entire visible cosmos into reachable inheritance. There remains a difference between the realm where effort can accumulate and the realm the universe itself removes from all shared continuation. The farthest place humans could ever reach would therefore still be bounded by cosmic law, even if human form, patience, and technology changed beyond anything our present century can emotionally house. Wormholes, warp drives, and other speculative devices often appear at this point in the imagination as possible escape clauses. They are worth mentioning precisely because they reveal how strongly the mind wants a loophole. If space can expand, if horizons can exile, then perhaps some deeper geometry offers a tunnel through which civilization might evade the old arithmetic. General relativity does admit strange structures mathematically, and speculative physics keeps such possibilities alive at the edge of thought. Yet none of this currently gives a reliable basis for civilization planning. Traversable wormholes appear to require conditions far beyond known engineering and perhaps beyond physical permissibility. Warp concepts tend to accumulate their own extraordinary requirements. More importantly, even if some exotic route existed, it would not automatically answer the philosophical question. Reaching another region by a hole in geometry is still not the same as proving that the entire universe is open without remainder. It merely relocates the frontier into another layer of law, so the script should let the speculation flicker without surrendering to it. Humanity may discover more than we know. Physics is not finished, but under what is responsibly understood now, the final answer still leans toward limit. A civilization might become astonishingly wide. It does not follow that it becomes cosmically unbounded. Then comes perhaps the strangest thought of all. If the long-term reachable realm is limited, that does not necessarily make it small in any human sense. The local group alone contains multiple major galaxies and many smaller ones. A civilization distributed through that bound family over billions of years could still become so rich, diverse, and internally vast that no individual branch would ever experience it as a mere neighborhood. The final cage, if one insists on calling it that, may still be larger than anything the human imagination can inhabit in one moral glance. This matters because the language of limitation can sound smaller than the reality it describes. To say that humanity may one day be mostly confined to gravitationally bound structures does not mean it is confined to a village. It means it may inhabit a future realm so enormous that even inside its limit, history can branch into more worlds, bodies, archives, ecologies, and traditions than present civilization can count meaningfully. The wall, if it exists, stands so far away that most of what matters to sentient life may happen long before it is approached emotionally. There is therefore a paradox in the answer. Yes, there is likely a definitive frontier. Yes, the universe probably withholds full access to itself. And yet, the reachable realm may still be so staggeringly rich that for most descendants, the experience of life will not be one of confinement, but of superabundance. The wound of limit belongs more to philosophy than to daily survival, at least until very late cosmic ages. Time, however, does not only widen possibility, it multiplies difference. Even if humanity reaches only a fraction of what is visible, that fraction may be enough to turn one species into a branching family of many humanities. Populations adapted to low gravity, heavy radiation, ocean worlds, rotating habitats, machine symbiosis, or deliberately modified cognition may drift so far from one another that the very subject of the question changes. What is the farthest place humans could ever reach? Which humans? In what form? Carrying what memory of origin? This does not weaken the grandeur of the problem, it deepens it. The future frontier is not only physical, it is definitional. 1,000,000 years, let alone 100 million or more, gives enough time for bodies, cultures, and minds to diverge profoundly. The farther out the species goes, the less likely it becomes that one branch can speak for the whole. The final frontier may therefore not be crossed by humanity as a single coherent subject, but by a great genealogy of descendants who still regard Earth as origin while scarcely resembling one another in form, law, or longing. That possibility gives the story its real scale. Reaching farther means becoming more. Every new region inhabited would also be a new interpretation of what the inheritance of Earth can be. And what of memory? If the future stretches across many stars and many centuries, the origin world will begin to recede not only physically but emotionally. Earth may survive as archive, ritual, scripture, political ancestor, scientific benchmark, or object of pilgrimage. For some branches it may remain intimate. For others it may feel like sacred geology from a prehistorical age. The farther humanity goes, the more its first home risks becoming symbol rather than sensation. This matters because frontiers are not only places we approach, they are also places from which we depart. The ultimate reach of civilization may therefore be measured partly by how much of its origin it can still carry without falsifying it. Can a people under another sun remember oceans honestly if none among them has seen one? Can descendants in artificial worlds keep Earth from collapsing into myth so simplified that it no longer deserves the name memory? Perhaps the greatest far-distance institution in the human future will not be the ship or the engine, but the archive. If that is true, then the farthest place humans could ever reach is also the farthest place origin can still remain legible. A civilization that goes wide enough may spend as much effort preserving truth about where it came from as building routes to where it is going. One way to feel the scale more honestly is to stop thinking like a tourist and start thinking like a civilization. A tourist asks how long it takes to get somewhere. A civilization asks whether continuity can survive long enough for somewhere to become part of a living system of exchange, memory, and return. This distinction matters because many places that can be touched once may never become meaningfully reachable in the deeper historical sense. A single desperate ship might cross a particular gulf under extreme conditions. That does not mean a stable road has been opened. Reach, in the strongest form, means more than contact. It means that lives, goods, knowledge, law, affection, and consequence can circulate with enough continuity that the place entered becomes part of a durable human world. By that standard, the frontier grows harsher. The farthest place a lone vessel could physically stumble toward is not identical to the farthest place humanity could truly inhabit as an extension of its future. A ship that arrives at some remote destination after centuries, too broken to send successors, too fragile to sustain local reproduction, too isolated to create a second launch, may still count as a heroic arrival. But it would not yet count as civilization taking root. The ultimate reach of the species must therefore be judged by recurrence. Can arrival happen more than once? Can what is reached become a new source of reaching? Can the place joined to history participate in history rather than remain a single miraculous exception? This is why the question becomes so severe at cosmological scales. The universe may contain regions that are physically imaginable as one-time arrivals under absurdly patient conditions, and yet those same regions may never become part of a real human future because expansion, delay, and fragility prevent the establishment of any continuing relationship. The farthest place humans could ever reach is not just the last spot a heroic machine can touch. It is the last place where continuity itself can still take root before the structure of the universe makes recurrence impossible. There is also a more intimate frontier hidden inside the large one, the frontier of return. Human beings often underestimate how important return is to their idea of exploration. Even when missions are understood to be one way in practice, the moral imagination of exploration still carries an echo of return. If not the people themselves, then at least their messages, their findings, their descendants, their influence, their recovered artifacts. Something must come back into a recognizable stream of shared history. Return is what prevents courage from feeling like abandonment. Return is how exploration becomes civilization rather than disappearance. At the interstellar and intergalactic scale, however, return becomes less secure. Not because the outward journey is always impossible, but because every increase in distance and delay weakens the reciprocity that makes return emotionally intelligible. A settlement beyond a certain threshold may still receive signals from its origin for a time and still send signals back, but if the exchange is measured in centuries, then return has changed species. It is no longer the return of sailors or even astronauts. It is the return of archives, of civilizational fossils still technically alive. Information arrives, but the world that receives it may no longer be the world that sent the original question. This means the farthest reachable place may also be the farthest place from which meaningful return remains possible. Beyond that, exploration becomes a kind of severance, even when material survival continues. A branch of humanity might thrive there, love there, build there, and still be so delayed in relation to its origin that common history has effectively ended. The final frontier, then, is not just the limit of movement. It is the limit of mutual belonging. Imagine a civilization spread through much of the Milky Way, perhaps with outposts in dwarf companions and long-term ambitions toward Andromeda. Even in such a magnificent future, daily life would still be lived under local skies, local laws, local ecologies, local emergencies. Children would still grow up inside one gravity, one language family, one school system, one set of songs about origin. The map of humanity might become galactic in extent while remaining provincial in experience. This matters because it reminds us that no one ever lives inside the whole frontier. They live inside one province of it while inheriting stories about the larger pattern. That structure of lived localness may be one of the reasons the final cosmological limit would hurt philosophers more than ordinary citizens. Most people, even in an interstellar future, would still experience their lives through work, intimacy, weather or its engineered equivalent, institutions, illness, beauty, family, and whatever moral order their local world sustains. The fact that some broader horizon of the visible universe remains unreachable would not necessarily burden daily existence. It would instead become part of metaphysics, part of how civilizations explain scale to themselves when they lift their eyes beyond what any one person can inhabit directly. This does not make the question trivial, it makes it mature. The final frontier may be less a practical frustration than a permanent reminder that no matter how wide the species becomes, reality still exceeds possession. That reminder could become one of the great stabilizing ideas of a future civilization. It might prevent expansion from hardening into totalizing arrogance. The universe would remain a teacher even after it had become partially inhabited. The late-time future of the cosmos adds another layer of sadness to the answer. If dark energy continues to dominate cosmic expansion, then more and more of the visible universe will slip beyond meaningful access and eventually beyond meaningful visibility for far future observers who lack our present archival inheritance. A civilization born very late might look out and see far less evidence of the wider cosmos than we see now. Distant galaxies would have faded beyond practical observation. The sky would feel poorer. The large-scale web of structure that teaches us today about the universe's grandeur might no longer be available in the same direct way. This means our own era occupies a strangely privileged position. We live early enough to see much of the universe before accelerated expansion has hidden so much of it from local observation. We can still measure the great structure. We can still infer cosmic history from a sky rich with evidence. Future civilizations may possess greater power and yet inherit a lonelier map. In that sense, the farthest place humans could ever reach is shadowed by another truth. The farthest place humans could ever know may, in some respects, be more available to us now than to descendants born in a much older cosmos. That reversal is worth pausing over. Progress is often imagined as a clean increase in access, as though later always means more. Cosmology suggests something subtler. Later may mean greater local mastery, but narrower direct vision of the whole. The frontier of knowledge and the frontier of travel are related, but not identical. A very old civilization might reach more physical places within its causally bound future while seeing less of the wider universe than a younger civilization able only to wonder. The cosmos gives and withholds on different clocks. There is also the profound question of whether human reach should include probes, machines, archives, and forms of delegated presence that fall short of habitation. A robotic probe can go where a living society cannot yet survive. An autonomous observatory can enter regions no biological crew could endure. A self-replicating industrial system, if such a thing were ever safely built, could spread material influence into places that no ordinary citizen would ever call home. So where does one draw the line? Does humanity reach a place when one of its instruments arrives? When one of its descendants settles? When memory and law can circulate there? When the region becomes part of a reciprocally inhabited future? The answer depends on what one values most in the word reach. If the question is purely physical, the frontier may be widened by machines enormously. If the question is civilizational, the frontier contracts again because tools are not the same as worlds. A sensor array orbiting a distant star is not yet a human province in any meaningful moral sense. A scattered cloud of machines does not automatically count as history unless history can live through it. This distinction suggests a layered answer. Humanity may send its instruments very far indeed, perhaps farther than living communities can follow for a long time. It may learn the far cosmos before it can dwell there. But the farthest place humans could ever truly reach, if reach means the extension of lived and self-renewing civilization, will remain bounded by stricter conditions than the farthest place a machine can briefly touch. The ultimate frontier of life is narrower than the frontier of information. There is another limit that matters almost as much as the cosmological one, and that is the limit of institutional coherence. People often imagine long-distance expansion as though the main challenge were propulsion, shielding, and life support, but a civilization spread across light years would also face a slower and perhaps more dangerous problem. How far can common purpose survive before delay turns unity into ritual rather than reality? A message that takes years, decades, or centuries to cross between two branches of humanity cannot preserve the kind of political or emotional immediacy on which ordinary civilizations are built. Law begins to drift, language bends, priorities separate. Even shared memory begins to thicken into ceremony rather than conversation. This matters because the farthest place humans could ever reach may not be determined only by the laws of physics outside the ship. It may also be determined by how much inward fragmentation the species can absorb before its scattered branches stop thinking of themselves as one future at all. An outpost 20,000 light-years away may remain physically human, historically descended, and technically alive. But if its culture, law, and self-understanding have diverged so completely that it no longer experiences any practical belonging to the older web of humanity, what exactly has reached that place? A civilization can widen faster than its own sense of continuity. It can succeed outwardly while dissolving inwardly. That does not make the expansion unreal. It simply makes it plural. The human future may become a loose forest of related lineages rather than one coherent tree. This means the ultimate frontier is not only the last physically accessible region, it is also the farthest point at which the concept of a common human future still retains meaning stronger than ancestry alone. Beyond that, what continues may still be wondrous, but it belongs less to one civilization and more to a family resemblance spread through time and stars. Biology would sharpen this problem. Human bodies are not neutral vehicles that carry culture unchanged across all environments. Gravity matters. Radiation matters. Closed ecologies matter. The nutritional texture of life matters. Artificial days, altered gestation conditions, different disease pressures, long residence in rotating habitats or subsurface oceans or engineered climates, all of this would begin pressing on physiology as well as imagination. Some branches of humanity might preserve Earth-like bodily conditions with extraordinary discipline. Others may decide that adaptation through biotechnology is not merely acceptable but responsible. Over enough millennia, the difference between those choices could become historically enormous. A civilization living on several worlds within one star system already begins to diversify. A civilization distributed across many stars for millions of years may eventually produce descendants who inherit Earth not as their body's norm, but as one ancestral template among many. In that case, asking what humans could ever reach becomes inseparable from asking what humanity is willing to become in order to go farther. If the farthest reachable places demand altered bodies, altered minds, or altered relations between biology and machinery, then the horizon is not only geographic, it is transformative. This does not mean the human future must become alien to itself, but it does mean the frontier is probably crossed in stages of self-revision. One branch may remain devoted to preserving recognizable human baselines. Another may redesign its sensory range for dimmer stars. Another may adapt to low gravity so thoroughly that returning to Earth-like conditions becomes painful or impossible. Another may merge heavily with machine systems for memory, repair, or cognition. Each of these would still claim the human inheritance differently. The farthest place reachable may therefore be the place where identity itself becomes the final form of propulsion. Economics would impose their own frontier as well. It is tempting to imagine the far future as a steady march of technical achievement, but all distributed civilizations must still solve the old problems of energy, labor, risk, and incentive. A system can only launch new settlements if it possesses enough surplus to survive the loss. It can only keep long lines of exchange alive if the benefits of continuity outweigh the cost of delay. It can only maintain large archives and deep infrastructure if enough people believe that preserving continuity is worth present sacrifice. None of this is automatic, so there may be vast epochs in which the human frontier slows not because the universe has become physically inaccessible, but because civilization has turned inward. Regions already settled may choose depth over width. Old habitats may require renewal so extensive that outward projects seem indulgent. Political trauma, ecological near collapse, or generations of cultural reflection may produce long pauses in expansion. A people can know that more stars are technically reachable and still decide for centuries at a time that wisdom consists in refusing to multiply itself thoughtlessly. This makes the question richer and more honest. The farthest place humans could ever reach is not simply the farthest place physics permits. It is the farthest place a civilization remains willing to justify reaching. Desire has an economy, ambition has seasons. The future may therefore unfold not as a clean outward march, but as waves of expansion separated by ages of consolidation, remorse, beauty, exhaustion, and renewed calling. The final frontier remains there, but civilizations do not walk toward it in one mood. There is also the possibility that the greatest barrier is not distance but meaning. A species can survive only so many generations on inherited momentum before someone begins asking a fatal question: why continue? On a planetary civilization, that question can be dispersed among billions of private answers. On a distributed interstellar civilization, especially one built on long-duration settlements, the question acquires structural importance. Why launch another generation ship? Why seed another system? Why turn another mass of rock and metal into habitat? Why accept still more delay, still more divergence, still more widening of the human map if no individual consciousness can hold the whole result as one life? This is not a trivial philosophical complaint. It could become the actual brake on expansion in certain eras. Some branches of humanity may decide that inward richness matters more than outward reach. They may perfect art, contemplation, ecology, local justice, memory preservation, or machine-augmented forms of inner life so intricate that the old migratory impulse begins to look adolescent beside them. Others may continue to feel called by distance almost religiously, as though the stars are not opportunities but obligations. Between these two temperaments, the future may oscillate for ages. In that oscillation, there is another kind of frontier. Not the last reachable place, but the last place civilization still cares to reach before it discovers that an infinite appetite for expansion is not the only form of greatness. The universe may impose hard limits from without, but intelligent life may also choose limits from within. Those chosen limits matter because they show that maturity may consist not only in going farther, but in knowing when farther has stopped being the deepest available good. And yet one should not romanticize restraint too quickly. There are threats that make expansion more than a taste. A civilization confined too tightly to one world or one star remains vulnerable to catastrophe concentrated in that system. Asteroid impacts, stellar evolution, ecological collapse, war, engineered pathogens, machine failures, political fanaticism, all these become less terminal if life is widely spread. Distance, in that sense, is not only ambition, it is insurance. The farther humanity goes, the harder it becomes for one local disaster to count as species-level extinction. This introduces another moral complication. Expansion can be criticized as hubris, yet it can also be defended as prudence. A civilization that refuses to distribute itself may be choosing ethical tidiness over long-term survival. A civilization that expands recklessly may be choosing survival rhetoric as cover for old appetites of domination. The right future lies somewhere between these poles, and that is one reason the question of the farthest reachable place feels so profound. It forces the species to ask not merely how far it can go, but what kinds of motives remain honorable at different scales of going. Perhaps that is why the likely final frontier being causal rather than geographical matters so much. It denies both laziness and arrogance. It says, yes, go farther, because your future is larger than one planet and perhaps larger than one star, But also understand that even justified expansion does not purchase the whole universe. There remains a boundary before which prudence and grandeur may still cooperate, and beyond which reality itself withdraws the offer. All of this leaves us with a final emotional paradox. The universe may deny us total access and still offer more than enough room for an almost unbearable abundance of futures. The likely limit imposed by causality and expansion is real, but it is so remote, so large, and so internally rich that humanity could spend ages unfolding inside it without ever exhausting its moral, artistic, political, and scientific possibilities. To learn that there is a final frontier is therefore not to learn that our future is small. It is to learn that even a vast future remains part of a larger order it did not create. That may be the healthiest answer a civilization can receive. Too little room produces despair. Imagined infinite room can produce recklessness. A finite but immeasurably rich, reachable cosmos offers something better: seriousness. It tells us that what lies ahead is magnificent but not ownerless, open but not without law, vast but not infinitely permissive. The stars would still call, the galaxies would still blaze. The local bound future would still exceed any single human lifetime or culture, and beyond all that there would remain a silence that no engine can negotiate away. At the practical level then, the answer begins to sharpen. In the near and middle future, humanity could plausibly reach nearby stars, perhaps many nearby stars, and over immense spans perhaps a significant portion of the Milky Way through branching settlement rather than single heroic voyages. Given enough endurance, it might also spread through the wider gravitationally bound family of the local group, or at least send lasting branches toward its major members. Beyond that, the future darkens under the pressure of accelerating expansion. The broader observable universe would remain visible in part, but much of it would not remain available as shared destiny. So the final frontier is not the edge of the visible universe, it is the edge of causal belonging. It is the limit beyond which no amount of patience, unless physics changes more radically than current understanding allows, can restore mutual participation in history. That frontier moves, deepens, and must be interpreted carefully, but it appears real. The universe is not infinitely open to civilization in the practical sense. It is partly hospitable to our future and partly forever withdrawing from it. This is not a disappointment, it is a revelation. It means the cosmos is not a simple stage awaiting indefinite settlement. It has its own structure of invitation and refusal. There is something emotionally important in accepting that. Modern imagination often swings between two fantasies. One says humanity is tiny and doomed to remain local forever. The other says there is no meaningful limit once intelligence becomes sufficiently advanced. Reality appears harsher and more beautiful than either. We are not confined to one planet or perhaps even one star. With enough survival, care, and continuity, our descendants could go astonishingly far. Yet they would still live inside a universe that keeps some distances absolute, some futures separated, and some visible things forever beyond the reach of dwelling. This intermediate truth is the most mature one. It gives ambition without delusion. It lets the future remain magnificent without pretending that magnificence means omnipotence. The farthest place humans could ever reach may still be unimaginably far by any human metric, and still not include all that our telescopes reveal. In that sense, the ultimate frontier would preserve humility at the very moment of greatest expansion. Perhaps every civilization worthy of the stars must learn that lesson. Not all horizons are there to be crossed. Some are there to teach scale. So is there a definitive border to our future? Probably yes. Not a wall of stone. Not a rim around the universe. Not a last signpost where matter ends and void begins. A deeper boundary than that. A causal boundary shaped by expansion, gravity, and the finite openness of space-time to relationship. Within it, humanity or its descendants could become vast beyond current moral imagination. Beyond it, the visible cosmos may remain forever a spectacle rather than a homeland. That answer leaves us in a beautiful position. The future is not infinite in the careless sense, but it is still larger than almost any dream civilization has yet had the courage to carry honestly. Nearby stars are not the end. The galaxy is not the end. The local group may not even feel like an end to those patient enough to inherit it. Yet somewhere beyond that expanding family of reachable history, the universe begins to close. And that may be the strongest ending of all. The farthest place humans could ever reach is not merely a destination. It is the place where courage, patience, engineering, memory, and cosmology finally meet and discover that the universe has answered. Not with total refusal, not with total permission, with a frontier worthy of a serious species, immense, tragic, and real.